Okay, hi. And today we're here to talk about rocks and their formation, and we're going to look at the rock cycle as well. So the main types of rock we're going to look at are, we're going to start with igneous rock, we're going to move on and discuss sedimentary rock, and finally look at metamorphic rocks as well. Okay, let's crack on and talk about igneous rocks. Now igneous rocks form from a molten state. So when molten rock or magma cools over time, it forms a crystalline type of rock called igneous rocks. And there are two basic types, as you can see on the diagram up here. First of all, we've got intrusive igneous rocks. These form underground, where the molten rock or the magma cools and it doesn't reach the surface before it's solidified. Over time, the rock above this will have been weathered away, and eventually this blob of intrusive igneous rock is exposed to the air. Now the other type are called extrusive, and these are the ones we see a lot more of because they actually emerge from the ground, and we often see these as volcanic activity. So these extrusive igneous rocks, they cool when they get out of the Earth's crust, and they cool above ground level. And we've got some examples of different igneous rocks here. So let's first start off with obsidian. Now you can see here, this rock is very, very glassy. It's extremely small crystals in size, and this forms when a rock is blasted out of a volcano or some other vent into the Earth's core, and this is the crystals basically form. They don't have time to get very big at all because it's cooled very, very quickly. So it's blasted out of the volcano, as you can see here, and as it emerges, it cools instantly to form extremely small crystals, and it looks like glass basically. Some people call it volcanic glass. If we move up the scale a bit and look at granite, granite is quite a common igneous rock. You can see form these different minerals, and you can see in here the crystals are much bigger than obsidian. You can actually see the crystal size. That's because granite, it's taken longer to cool. So over time, the granite is also an intrusive rock. It doesn't actually cool above the ground surface, it cools below it. So the crystals have more time to get a bit bigger. Lastly, you can see this one here, basalt. Now you might recognise this photo. This is the Giant's Causeway in Northern Ireland, and this rock has had a very, very long time to cool underground, this intrusive igneous rock. And so over time, you've seen these huge hexagonal columns have formed in the basalt when it was in a molten state, and as it cooled very, very slowly, these crystalline structures could form over many, many thousands of years. And then over time, you can just see in the background, this cliff line here, the rock above the basalt, what they call a batholith, which is a big, massive blob of igneous rock that's cooling. These rocks have been weathered away, exposing the crystals underneath. Okay, and now we're here to look at sedimentary rocks, the second of our three types. And you can see the diagram at the top here. Sedimentary rocks basically form where bits of the Earth's crust, like bits of soil and sand and other types of rocks, they're worn down by the elements like wind and waves and the weather, and these small sediments or clasts, these bits of rock, are moved around and then deposited in different places. And you can see by the diagram here, these layers, they show you that over time, these layers of deposits that are formed can be what they call cemented. So they're squeezed, all the water is squeezed out of them, they become harder, and they form a new type of rock. And it doesn't have to form underneath the ocean or in the ocean, but some sedimentary rocks do form in the ocean. And one of those, you can see here on the right hand side, is limestone. Limestone is primarily made up of the shells of marine creatures, so calcium carbonate forms the large part of limestone, and over time all the liquid is squeezed out of the rock and it is cemented to form this very, very hard rock we see here. Typically the sort of place that limestone forms in is shallow, warm tropical seas, a bit like the Caribbean nowadays. If we think about rocks that are not formed underneath oceans or in oceans, then sandstone is a good example. And they're very, very common. Sandstone rocks obviously form where the sand has been, or the grains of rock and minerals have been weathered away from the rocks on the surface. They forms above ground, and sandstones are very different depending on where they've come from. So if it's a granite weathered to form a sandstone, or maybe another type of rock weathered to form a sandstone, it'll have a different chemical structure. And lastly, there are many, many types of sedimentary rocks, but our third example here is coal. And sedimentary rocks don't have to just be non-organic in origin. Coal is constructed and composed of the bodies of small creatures, and over time these bodies get vitrified, get formed into rock because they get compressed, and obviously the carbon content of those bodies is what forms the energy content of coal. And this one you can see here is anthracite, which is an extremely hard, glassy, not very dusty form of coal, burns with an extremely high calorie content. And these coal and other energy source sedimentary rocks like this, they're formed along the margins of river basins. Okay, lastly we're going to talk about metamorphic rocks. Now, metamorphic rocks basically are rocks that have been altered by heat or by pressure or both. And you can see in the diagram here, you can see the arrow pointing to this area, this destructive plate boundary, which you might have heard about in geography, where one rock is being pulled down or subducted underneath another tectonic plate. And as the plate gets pulled underneath, it's going to get buried. In other words, it's going to get deeper and deeper into the Earth's crust. And this type of metamorphism, where a massive volume of rock is buried, is called regional metamorphism. The other type of metamorphism you can see is near this area of igneous rock that is intruding into the crust, intrusive igneous rock. Right on the margins, where it touches what they call the country rock, the rock nearby, it's going to have what we call contact metamorphism, where it actually, where it touches another type of rock, it's going to alter it by heat. And one example of that is this first rock on the right hand side, Hornfels, which is a rock that's been baked, and you find this next to big areas of granite, for example. It bakes and it's extremely hard, and it rearranges all the minerals inside it. Another example of a type of metamorphic rock is slate, and this is a good example of a regional, what they call a low-grade regional metamorphic rock. It's where a huge volume of rock has been buried fairly deep down the Earth's crust, but not massively deep down. That's why it's a medium-grade metamorphic rock. And what it does, as you can see if you've held a piece of slate before, it's very, very, you can see very laminate. You can see these flakes of slate, and it's got really what they call cleavage planes, where the layers are very obvious in the rock, and that's because the pressure has aligned all the minerals in one direction. That's why it makes great roofing tiles. Third example we've got here is a rock called gneiss. That's how you pronounce it, silent G, gneiss, and that's further. Basically it's another type of regional metamorphic rock, like slate, but it's where the rock has been buried much, much further down. And here you can see all the structure of the original rock has just gone. And the rock has been just remineralized. It's basically messed up all the minerals, all the structures. You can't see the original rock, and it's now banded into these different minerals here. And that shows it's been buried very, very deep down. Thank you very much.